Hi guys, today you're going to be taking notes on objective 7.1a. I apologize, I'm having a little trouble with my I'm coughing a bit, so I'll be stopping and sipping water, and I may have to pause and cough a little bit. Anyway, we're 7.1a. Topic today is the trig functions, just the basics, and how they apply to the 30, 45, and 60 degree angles. Your essential questions, there are two of them. What are the 6 trig functions of acute angles? How do you determine the trig functions for 30, 45, and 60 degrees without using a calculator? So the basics here, hang on. Sorry about that. Are SOHCAHTOA, which is just an acronym to help you remember that sine is opposite over hypotenuse, cosine is adjacent over hypotenuse, this tangent is opposite over adjacent. And so we use that when we're trying to find trig values, when we're trying to find angles on right triangles. Okay, Greek letters are often used to denote angles, such as alpha, lowercase a in Greek, beta, they're all lowercase. Even though that looks like an uppercase B, it's not. Gamma, theta, phi. Okay, there are others, but these are the most common that I see in the trig textbooks that we use. Okay, so let's take a look at this right triangle I have from the perspective here of angle theta. When you're doing trig, what you always do is you focus on the angle. That's the place you start. And then you label the triangle, or you look at the triangle from that perspective. So this leg over here is opposite of angle theta. This leg down here is adjacent to angle theta. And of course you have the hypotenuse here. And so there's your O, there's your A, and there's your H. Okay? All right, so now that we've got those basic pieces of information down, let's talk about the fundamental trig functions. Okay, it's really critical to learn these. So the lengths of the sides of the triangle are used to define the 6 trig ratios in respect to the acute angle theta. Remember, you have to start from the angle's perspective. So the sine of theta, sine is OH, is opposite theta over hypotenuse. Cosine is AH, adjacent to theta, over hypotenuse. And tangent is OA, opposite theta, over adjacent to theta. Okay, so angle goes here, side measures go here. Now, these other 3 trig functions you may not be familiar with. These are cosecant, secant, and cotangent. And you'll see in a little bit how those are spelled. But cosecant, secant, and cotangent. Well, cosecant is the reciprocal of sine. So it's H over O. So this is hypotenuse over opposite theta, or H over O. A secant is H over A. So secant would be hypotenuse over adjacent theta. And cotangent is A over O. So it's adjacent theta over opposite theta. So what you're doing is basically writing ratios with all of the sides of the right triangle in all of the different ways that you can organize the sides of the right triangle. Okay? And remember, your calculator only has the sine, cosine, and tangent functions. So when I'm giving you measures in secant and cosecant, cotangent, you're going to have to do some conversions in order to use your calculator. But that's for another day. Okay, let's take a look at the example here. We have example in the right triangle showed at the right. Find the 6 trig values for theta and alpha. So remember what I told you. You're going to start from the angle's perspective and label the angle out so that you can write your trig function. So we'll start with angle theta. Here's angle theta. In respect to angle theta, this would be your opposite leg. or your opposite side, here's your adjacent side, and of course here's your hypotenuse. So now that you have that labeled, you can say the sine of theta, which is OH, is opposite, which is 12, over hypotenuse, which is 13. And then you can just hop over to cosecant of theta, which is just H over O, or the reciprocal of that, and you get 13 over 12. You know one, you know the other. Okay? Cosine of theta, A over H, is just adjacent over hypotenuse. Adjacent is 5, and hypotenuse is 13. So we can hop over to secant of theta, which is H over A, or hypotenuse, 13 over adjacent, which is 5. And then we just have the last two to go. Tangent of theta, which is OA. Tangent of theta is opposite over adjacent, so 12 over 5. And then cotangent of theta is A over O. Get theta in there. And so A over O would be 5 over 12. Okay? So in respect to angle theta, those are the 6 trig values. Now, let's look at angle alpha. Now, what I'll do is get you started, but then pause the video and then find all the 6 trig functions and then press play to see if you got them right. So we'll get started. At least we'll label the triangle. So we're now looking at the triangle, so I'll put a little I right here. I'm looking at the triangle from this perspective. Okay, so opposite, adjacent, hypotenuse doesn't change. So pause the video, write down the 6 trig functions, and then come back and see how you did. Okay, so there you have your values. You could take a minute to look at some connections here. You'll notice things like the sine of theta is the same as the cosine of its complementary angle of alpha. It's interesting. You'll notice that the cosecant of theta is equal to the secant of alpha. That's a weird thing that my iPad did. If you look at the patterns, you'll see some things start to emerge, but don't overwhelm yourself. Let's just keep going. Okay, so the reciprocal functions, we've already talked about them. Here you can see that I've spelled out the words for cosecant, secant, and cotangent. They are the reciprocal functions of sine, cosine, and tangent, respectively. So cosecant goes with sine, secant goes with cosine, and cotangent goes with tangent, as illustrated already. But sometimes when we're plugging that information into our calculator, since your calculator doesn't have a cosecant button, you do have to do a little manipulation. And so there's an alternate equation for the cosecant of theta that we use when we're using our calculator. Cosecant of theta is the same as 1 over the sine of theta. Okay? Secant is equal to 1 over cosine theta, and cotangent is equal to 1 over tangent theta. Again, tomorrow when we take notes, you'll see why this form of these 3 functions is really useful. So here we have an example that asks us to take the sine of phi, which is 4/5, cosine of phi 3/5, and tangent of phi 4/5, and find the cosecant, the secant, and the cotangent of phi. So here's what we know. The cosecant of phi is equal to 1 over the sine of phi, and that means it's 1 over sine of phi, which is 4/5, and that's a complex fraction. We don't really like that. So 1 times the reciprocal, and we get the solution, 5/4. This is really important when we're doing calculator work. I know you want to skip it, but don't. So let's do secant of phi, which is 1 over cosine of phi. Cosine of phi is 3/5, so 1 over 3/5, which will change to 1 times the reciprocal of 3/5, 5/3, and we get 5/3. Last one. Cotangent of phi is equal to 1 over the tangent of phi, and the tangent of phi is 4/3. So 1 over 4/3, which is equal to 1 times 3/4, and so we get the answer 3/4. And you can see as I go through these identities, what we call them here, you can see that this is actually true, that the cosecant of theta is either 1 over the sine of theta, or up here we saw it as the hypotenuse over the opposite. They ended up being the same values. Okay, on to the back. Here's some more information that's important. Triangles are similar, and here's the symbol for similar, if their corresponding angles have the same measure. The lengths of their corresponding sides are not in the same measure, but they are in the same ratio. In other words, they're proportional to each other. One will just be a miniature of the other. Observe, down here in our picture, we want the sine and cosine tangent values of beta in the triangle below. Let's prove that these triangles are similar. So I'm going to grab my red pen, and this is going to be triangle 1. So we are looking at angle B, and we're interested in the sine, cosine, and tangent values of angle B. So here's angle B, here's my perspective. So I'm looking at the opposite side, I'm connected to the adjacent side and to the hypotenuse. So if I'm looking for triangle 1, the sine of beta, sine is OH for SOHCAHTOA, so O is 3 and H is 5. We also have to do the cosine of beta per the instructions, A over H. So A is 4 and H is 5. And tangent of beta, OA, so O over A, TOA, is O over A, that's 3 over 4. Now none of those fraction values can be simplified, so there we have that done. I'm going to go ahead and switch to my green pen, and I'm going to look at triangle 2. So here's angle beta, again down here. Here's my eye. I'm looking at the triangle from this perspective. Here's the opposite side. Here's adjacent to, and here's hypotenuse. So for triangle 2, the sine of beta is opposite over hypotenuse, which is 12 over 20. Now that doesn't quite look like 3/5, but when I reduce it, it is. It's interesting that the sine of beta in both situations was 3/5. Okay, corresponding angles have the same measure. Cosine of beta, A over H, is 16 over 20, reduces down to 4/5. And so, regardless of the size of those two triangles, sine and cosine have the same trig values. Finish it up with tangent of beta. On triangle 2, that's 12 over 16. We reduce that also down to 3/4. And so we can draw this conclusion. Therefore, the trig function values of any angle, theta or beta or alpha, whatever I choose, depends solely on the measure of the angle. Measure of the angle. Not about the size of the triangle. You have a tiny 30-degree angle making a tiny triangle, or you can have a massive 30-degree angle making a right triangle. Okay? All right. Now, something that you need to know, and now we're going to put all of this into some problems where you're going to have to do a little bit more work. You can find the other 5 trig function values of an acute angle when one of the function value ratios is known. So I'm going to show you how I do this. Even after doing thousands of these problems, I still do them the same way. So let's take a look at this problem. Notice it says an acute angle. If I know one, I can find the other 5 trig values. So this problem says if the sine of beta is 6/7 and beta is an acute angle, find the other 5 function values. So what I do is I sketch out a right triangle. Beta is an acute angle, so I know it's not the right angle, and I know the opposite over the hypotenuse because it's given me the sine. So I just sketch a right triangle. I don't think I did a very good job. Let me fix this up with a deeper angle here. Yeah, that's more like 6 and 7. And here's angle beta. Okay, and so that's my opposite of beta. Here's my hypotenuse. Okay, so I know I'm given the information that the sine of beta is 6/7. Well, without really doing any math, here's what I know. I can use the fundamental trig function that says that the cosecant of beta is just the reciprocal of the sine of beta. And so now I know that. But cosine is a over h. I need adjacent. The problem is over here, I don't know what a equals. However, I can use the Pythagorean theorem to find it. So when I'm looking for the side of a right triangle, I can either use the original version of the Pythagorean theorem. Now I typically use this version when I'm looking for the hypotenuse, or when I'm looking for one of the sides, the legs of the right triangle. Often I will do the hypotenuse minus one of the legs equals the other leg. So I'm going to choose this version. So 7 squared minus 6 squared equals a squared. That's 49 minus 36, so 13 equals a squared. Taking the square root of both sides, the adjacent side is the square root of 13. And so now I have that value as well, which means I can go ahead and finish out the other 4 trig values. So cosine of beta, which is a over h, is going to be the square root of 13 over 7, which leads me to the secant of beta, which is the reciprocal of that, which is 7 over the square root of 13. Now I am going to ask you to rationalize your denominators. So we're going to move that radical to the numerator by multiplying times the square root of 13 over the square root of 13, which just equals 1. And we're going to multiply. So 7 times the square root of 13 over the square root of 13 times the square root of 13, which is just 13. This is my preference, so please make sure you're rationalizing your denominator. Last 2, we have the tangent of beta, which is O over A, TOA. So tangent is 6 over the square root of 13. Again, we have this issue where we have the radical in the denominator, so we're going to rationalize by multiplying by the square root of 13 over itself. So that's 6 times the square root of 13 over 13. And there we have your tangent of beta. And then you want your cotangent of beta, and then you're done. Now remember, cotangent is just A over O. All right. So I think I'll just go ahead and flip this guy over, since that will pull the radical in the numerator without me having to rationalize to get there. And so there we have our solutions for the other 5 trig values. Okay, so do a sketch, use your Pythagorean theorem if you're missing a side, and then there you go. All right, last thing we have to do here is use our special right triangles, which we talked about the other day, but I'll remind you here in notes. For the 30-degree angle, the 45-degree angle, and the 60-degree angle, and notice I'm asking you to do this without a calculator. So remember that you have your options. So let's draw a 30, 60, 90. We'll just do a little sketch here. And remember the relationship of the sides. Doesn't matter the size of the triangle. The relationship between the sides, or the ratio of the sides, is x is the short leg, 2x is the hypotenuse, and the long leg is x times the square root of 3. And the other one is your 45, 45, 90 right triangle, which you memorized yesterday. Okay, and you remember that on a 45, 45, 90, that the legs are both whatever, the same length, because it's an isosceles right triangle, and the hypotenuse will be that value times the square root of 2. So if I'm asking you for the cosine of 45 degrees, I could go ahead and put my perspective here on this angle, and cosine is adjacent over hypotenuse, if you recall, and so I need the adjacent side and the hypotenuse. So the cosine of 45 degrees is equal to x over x times the square root of 2. And then all we need to do, of course, is simplify that, and we can get some values here. So I'll go ahead and cancel out my x's here. X divided by x is 1. And then we'll also rationalize the denominator per my preference. So we'll multiply times the square root of 2 over square root of 2, and we get 1 times the square root of 2 over 2. And let's see, this is the exact value of the cosine of 45. 45 degrees. I promise you, by the end of this semester, you will know that one by heart. Okay, cotangent at the 60. So remember that cotangent. I'm going to switch to a different color here. Cotangent is the reciprocal of tangent, which is TOA, and so we need A over O, right? So adjacent over hypotenuse. So I'm going to come over here to my 60-degree angle, and I'm going to put my perspective there, and I need the opposite and the adjacent. So here's our adjacent. Here's our opposite of 60 degrees. So we can say, okay, that is not a T. The cotangent is 60. Opposite, it's adjacent over opposite, so it's going to be x over x times the square root of 3. Pretty similar to the one we just did. We'll cancel our x's. X divided by x is 1. Multiply times the square root of 3 over the square root of 3, and simplify. So the cotangent of 60 is equal to, 60 degrees, is equal to the square root of 3 over square root of 9, which is 3. Okay, last one, and then we're done. Okay, so I'll grab one more color here. Let's see. I'll grab orange. Okay, so the sine of 30 degrees. So I'm going to come over here to the 30-degree angle, put my perspective there. Remember that sine is so it's opposite over hypotenuse. So from the perspective of 30 degrees, the opposite side is x, and the hypotenuse is 2x. So the sine of 30 degrees is x over 2x, and we simplify that by canceling the x's, and so we get the sine of 30 equals 1/2. Pardon me. And there you go. And so that's how you use your special right triangles to help you find those exact values of 35, 40, or 30, 45, and 60. Tonight your homework is on Canvas. You're doing assignment 7.1a, problems 1 through 27 odd.